Joining tables is really an essential part in relational databases. Now MySQL is a relational database. So what does relation mean? So over here, if you take a look at our orders table, I have already put some dummy data over here. So you can see the first order and its order number, its order date, and customer ID. Now what is this customer ID? Now obviously this customer ID is a foreign key because it's a reference to a customer. So instead of storing over here like all the customer information, we're just storing its ID. So this is the foreign key. And yes, employee ID is also foreign key. You can have as many foreign keys as you want. Now this is the primary key because it's an order ID. So if order ID is primary key, so this particular order, its order number is this, its order date, so when this order was taken, when this order was placed, and who placed the order. So customer number 3 placed the order. So if you go to customers table and look at our 3, you can see it's Muhammad. So Muhammad actually ordered it. So you can see we got all the information about Muhammad already. So instead of storing first name, last name, age, phone number, and email directly in the orders table, we just stored its reference, only its ID. Okay, now if you see the second order, it's like customer ID is number 2. So number 2 ordered it. So you can see number 2 is Alan Adams. So actually this guy actually ordered the second order. Okay, so order number is this, order date, and who ordered it. Now you can see 2 not only ordered the second order, he also ordered like 6th order because you can see the customer ID is 2, and also he ordered the 10th order, that is customer ID 2 again. Now let's take a look at our employee ID. Now what is this employee ID? Now okay, customer ID means who placed the order. Now employee ID, I put it because like while he placed the order, which employee was on charge, on duty. So to which employee did he actually communicate, like which employee actually was there while he placed the order. So that's about the employee ID. So you can see the first order, customer number 3 ordered it, and at that time employee 1 was there. So if you go to the employees table, you can see employee 1 is Syed Basim. So again, you can see we got the whole information about Syed Basim. Not only his name, we got name, job position, salary, joined at, about, and all that. So instead of storing all of this information in the orders table, which doesn't make sense, we just stored its reference. Now okay, so how did we actually know like which customer it is? So we had to like check the ID. Okay, it's ID number 2. Then we had to go to the customers table, check the second ID, and you can see this is. So that's a lot of work. We had to manually go and look. So that's no use. Why do we have to manually go and look? So we have a query in SQL where it does all of these behind the scenes. So that's called joining tables. So joining tables is really essential to know in relational databases. So as I already said, MySQL is a relational database. Now, so what you have to do is, like I'll say in a nutshell, in a summary, what we're going to do while joining tables. So you can see, so now instead of like customer ID, just customer ID, we will join the 2 tables, and during the output, not only customer's ID, but we'll get like over here, you can see customer ID is 3. So we'll get the information, the whole information about 3 over here. Okay. So it's not going to add in the orders table, only during the output it will be there. So in the orders table is not changed, only the output is changed. So if you can see customer ID 3 and employee 1. So this employee 1 whole data will come over here. So it's easier for us to see. Now again, I'm saying that data will not be put in the orders table, only during the output it will be visible. So you're going to join. So as you can already imagine, we're going to join the orders table and the customers table and also the employees table. First we'll join the orders and the customers table. So over here, first we have to select everything from the orders table, right? If I run this, you can see we got all the orders. We got customer ID and employee ID. Now for joining the tables, we have join like that. Okay. Join customers. We're joining customers, right? We're joining orders with customers. Then on, and we have to write the condition. On what condition we have to join? You can see the condition is the customer ID. Okay. The customer ID in the orders table. So this is the orders table, right? So the customer ID in the orders table should be equal to this ID column in the customers table, right? So over here you can see the customer ID. For example, I take 8. Okay, so the customer ID 8, okay, has to be equal to the ID column. So over here, I hope you understand this. So over here you can see the customer side. So this is the orders table. So in the orders table, the customer ID 4 should be equal to the 4 in the customers table, so the ID column. So I'll just write it and show you what we're doing. So we have like the customer's ID should be equal to customer.id. So the customer ID, what is this customer ID? So in the orders table, because we told like from orders, right? So MySQL is going to assume that this customer ID is in orders table. And yes, indeed, it's in the orders table. So in the orders table, the customer ID field, so for example, this 3 should be equal to customer.id. So customer.id means in the customer table, the ID column. So this 3 should be equal to in the customers table, the ID column. So over here, 3 over here. So that's actually how it is. So if I run this, you can see the magic was going to happen. We got an error, I guess, unknown customer.id. Oh yeah, because this is the customers table. You can see over here is customers, not customer. So that was a mistake. So wow, you can see this. We got already all the information. So okay, we got unexpected output actually. Oh no, nothing, sorry. So you can see we have order ID 1, okay, customer ID is 3. So this 3 ID, this whole thing is going to be getting the whole information. You can see the second order was placed by the second customer ID. So now SQL went to the customers table and grabbed the second ID. The second ID is what? This thing, Alan Adams. So this guy was selected. So you can see we got the whole information. Now actually I want to say that this information is not inserted into the orders table. So if you go to the orders table over here, select everything from orders. If you run this file, you can see the orders is same thing. We have just the ID and the employee ID. We don't have any other information. Joining actually during the output it shows that. So if you see, you got Hansen Ola over here, ID number 1. Now why this customer ID number 1 was selected? So you can see customer ID number 1 is Hansen Ola. Why was ID number 1 selected? Because we can see the customer ID is 1 over here. So that's why the first ID was selected. So that's about joining tables. So I'll say once more what we were doing. We're going to select every column, because we got every column in the output, you can see, from the orders table. And then in the orders table, we're going to join the customers table. Now based on what condition we should join the customers table? The customer ID, or for making you easy, I'll just write orders over here. So you can see in the orders table, the customer ID field. So in the orders table, the customer ID field should be equal to in the customers table, the ID field. So in the customers table, the ID field. So you can see in the orders table, for example, the second one, okay. So in the orders table, the customer ID field. So again, you can see in the orders table, so this is the orders table. So in the orders table, the customer ID field should be equal to in the customers table, the ID field. So in the customers table, the ID field. So over here, if the customer ID is 2, then it's going to select the second one, is going to select the customer with the ID 2 over here. So this whole information is going to be inserted over here in the output. So now if you want just like some things, like instead of selecting everything, maybe you want just like this. So order ID, and then maybe the order date, and then customer dot first name. Maybe you want like just like that. Now I'm mentioning customer dot first name because you can see we selected from orders table. So if I don't type this, then SQL is going to assume that the first name is in the orders table. Actually, this first name is in the customers table, not in the orders table. So I have to put like this. So customers dot first name. So if I don't type anything over here, it's going to assume that this order ID is in the orders table. Order date also is in the orders table. but the first name is not in the orders table, it's in the customers table. So you're going to get like customers.first name. If I run this, you can see we got only three information. We got order ID, order date, and customers.first name. You can see we got order ID, order date, and customer.first name. So that's about joining the tables. Now, if you like, instead of writing customers again and again, you can see we're writing customers. So this is actually a lot of, lot to write. So you can actually put, aliases. So I can just put like C. So instead of customers, I'm going to put C. That's actually the convention. You have to put like the first letter. So you can see instead of customers, I'm going to put C. So it's like this, customers space C. So wherever there is customers, now I'm going to put C dot like that. And for orders also I can put, so instead of orders, I'm just going to put O over here. So I'll put like O dot. Over here also, instead of orders dot customer ID, I'm going to put O dot. So now this O means orders because we put orders space O. And C means customers because we put customers space C. So if I run this, the output should not be changed. You can see no errors and the same output. So if you want to shorten the name, then you can use like this, or if you want to put the whole name, then don't worry, there is no problem in it. So I just want you to like make sure you really get it, the joining command. So if you don't get what is join, then maybe you could just rewatch the video, or you can just play around with yourself. You can just see this code and see what's actually happening, and you can write the code on your own. So that will actually make you more confident. So that's about joining the tables. Now actually I forgot to mention that this is an inner join. So if I type just inner over here, inner, nothing's gonna change. If I run this, you can see we got the same output. That because that is inner join. Now we have inner join as well as outer join. Now the differences I'll explain a bit later. So now this is actually inner join. So what we did till now is actually inner join. We also have outer join. So I'll be explaining outer join in a bit. Now before I get into the outer joins, I want to show you how you can join more than one table. So you can see in our orders table, we have the customer ID as well as employee ID. So the customer ID is referring to the customers table and employee ID is referring to the employee table. But in the output you can see, like first of all, I'll just select everything. So in the output you can see we have orders ID, order number, order date, customer ID and employee ID. But now we joined the orders table along with the customers table. So now for the third customer ID, we have the third customer. So we have all the information about the customer. For second one, we have second one. So we have all the information about the second one. So we successfully joined the customers table. But you can see we don't have any information about the employee. So if you see, we don't have any employee information. We just have the ID. Like this, we just have the ID. But for customers, we no longer have just the ID, but we have the customer ID as well as all the customer information because we joined customer. Over here, you can see we join customers along with orders. So that's why you can see all the customer information and not the employee information because we didn't join the employee table. So for joining another table, actually you have to just write the same thing again. So join. But this time you're joining the employees table. So employees, so the name of the table, and I'll just put like a small e. So instead of writing employees every time, I'll just write small e. On, then e dot. What is this? You can see employee ID. So O dot employee ID should be equal to e dot employee ID. So what we're doing is in the orders table, the employee ID field. So the employee ID, this is the orders table, right? Actually we joined the customers table, but this part is the orders table part. So over here you can see where the employee ID, employee underscore ID. So this employee ID should be equal to employee ID in the employees table. So the orders table employee ID should match with the employee table employee ID. So you can see this employee ID, so 0009 should be matching with the employees table 0009. So this part. So you can see over here. So this thing should match with this thing. So this is how actually, so earlier we joined the customers table and now we're joining the employees table. So if I run this, you can see both the tables should be joined. You can see order ID, order number. So this part is the orders part. And then we join the customer. So this is the customers part. And you can see we joined the employees table also. So you can see we successfully joined multiple tables with the orders table. So along with the orders table, we joined multiple tables. So that's about joining tables and joining multiple tables, how to join them. So we are joining them based on the condition. Now actually one last thing I want to mention without going to outer join is, first of all, I'll just remove this second join because to keep things simple. Okay, I'm just going to run this. You can see we got this. Okay, in the orders table you can see the second order was placed by the second customer. So by second customer over here. So that's completely fine. But what if we delete this customer? So just right click it, delete row. So now the second row is deleted. If I press apply, so it's going to run this particular command under the hood, because you remember we learned how you can delete it. So we're going to delete it and apply. You can see an error. Now what is that error? Cannot delete or update a parent row, a foreign key constraint fails. So what exactly is happening is, you can see, first of all, I'll just refresh the table. No, wait, I'll just run this whole query again. Okay, you can see the second one was not deleted. We got an error while deleting it. Now why we got an error? Because we mentioned that this order was placed by the second customer. So now this part has a relation with the second customer over here. Now if I delete the second customer, then it will be a problem, right? So now if you try to join the tables, you can see the customer ID, then we're joining with the second customer. Now we deleted the second customer, so the second customer doesn't exist. So you can see we got some problem while referencing. So that's why whatever row has a relation with something else cannot be deleted or updated, something like that. Okay, so over here customer ID 2 can never be deleted because it has a relation. Customer ID 3 also cannot be deleted. But over here actually some customers did not order yet. So you can see if you go to the orders table, we don't have number 9. So over here number 9 is Gopi. Okay, so number 9 didn't order anything. So over here number 9 has no relation with the orders table. Okay, so orders table is not referencing number 9. So over there I can just delete the number 9. So if I right click and delete row and apply and just run this, we got successful. There was no problem while deleting it. So if I run the whole query again, you can see number 9 is not there. Why is number 9 not there? It's completely deleted. When we tried to delete number 2, we got a problem because this order was placed by number 2. So it has a relation with it. So over here number 2 cannot be deleted. Then who ordered this customer? Then who ordered this order if number 2 is not there, if we delete the number 2? So that's actually the power of foreign keys, because this customer ID is a foreign key. So if I actually take a look, if I just type like describe shop.orders, you can see MUL and MUL. If you remember from the previous video, MUL means like foreign key. I don't know the full form, but MUL is foreign key. So this customer ID and employee ID is a foreign key. Okay, so over here customer ID is a foreign key. So foreign key actually ensures that anything which is related cannot be deleted or something like that. So over here an order, so actually just delete this part and run this part again. You can see the second order was placed by second person. So there is no way I can delete the second person because it has a relation with the orders table. So that's actually the power of foreign key. So foreign key always ensures that there is data integrity. So anything unexpected is not being deleted or updated or something like that. We cannot even change the primary key. So I cannot put like 5 over here. Now I cannot put like 100 over here. Why I can't put that? So I put over here 100 and apply. We got an error, the same error actually. Now why is it so? First of all, I'll run the whole thing again. You can see number 2, we got an error. Now we got an error because we are referencing customer ID 2. So if I actually change it to something else, there won't be any customer ID 2. So now to whom is this referencing? It won't be referencing to anything. So again, foreign key will not allow us to change data like that. But I can change data on Joe, the number 10. You can see number 10 hasn't ordered anything. Okay, so number 10 is like has no relation with the orders table. So if I'm changing to something else, it will be completely valid. So I'll just maybe change it to this number, for example, and press enter, and you can see apply. You can see that it was successful because Joe didn't have any relation with the orders table. If I run this whole query again, you can see the Joe table, the Joe ID is not changed. I'll just put it back to, I'll put it 9 over here, because why that random ID? I'll just put 9 over here, enter, apply changes, and it was successful because it didn't have any relation with the orders table. Okay, now we'll move with the outer join I've been telling you so far. The join we did till now is called the inner join. I'll just talk about a bit later why it is called inner join and what difference it has with the outer join. So till now we were doing the inner join. So you can see I wrote join customers. So first we're taking the orders and then we're joining it with the customers. So if I type inner join, so instead of just join, I'm typing inner join. If I run, you can see I get the same output because join and inner join is the same thing in SQL. So instead of inner join, which is like very long, I can just remove the inner and just keep the join. So it looks much short. So that's about like inner join. Why is it called inner join? Now before I go to the outer join, I want to talk about the left and the right table. So select everything from the orders table. So this is the left table and then we are joining it. So that's the right table. So you can see once we join it, you get like this. So first we're getting the orders table because we selected from the orders table and then we are joining the customers table. So first, so you can see orders table is in the left side, and if you scroll to the right, you can see the customers table is in the right side. So that's why it's called the right table and it's called the left table. Now if I just swap the customers with the orders, okay, so now nothing should change, but the order should change. Now customers, before it was the right table, you can see, but now first we're selecting the customers. So now customers is the left table and orders is the right table. So you can see the output order should change actually. So if I run, you can see first we had orders, but now first we have customers. So this is the left table and then we have orders, that's the right table. So that's the difference between the left table and the right table. Now I'll just go back like this, how it was. Orders as the left table and customers as the right table. Now if you see over here, I'll just run the whole query. Yeah, so you can see we have 10 orders, and in the 10 orders you can see first order was placed by customer ID 3, second order was placed by customer ID 2, third was placed by 4, and so on. But you can see not all customers have ordered something. You can see over here customer ID 9 is not present. If you go to the customers table, you can see we have customer 9 also, Joe. So over here customer 9, if you go in the over here in the orders table, I'll just go in the orders table over here. You can see over in the customer's ID, we do not have customer 9, the ID 9. So it means that customer ID 9 or Joe didn't order anything. Okay, so you can see 3 has ordered, 4 has ordered, 2 has ordered. 2 has ordered actually 1, 2 and 3 times. So there are 3 orders of number 2. 1 has ordered 2 times, like 2 different orders. 8 also has orders. So other all didn't order it. Okay, so it's not necessary that all the customers should order. So customers are there, but it's not necessary that all the customers should have an order, all the customers should order something. So you can see the order is actually not filled with all the customers, only the customers who have ordered something. So you can see over here, while we are joining the tables, we join the orders table with the customers table. But over here, the customers which have not ordered are not present. So only it joins 2 tables if both there have relationship. So over here you can see customer ID 3. So the third ID was joined. Customer ID 2 was ordered, so second customer joined. The customers which did not order, that is, which are not present over here in the customer ID field of the order table, those customers are not joined. Okay, because of this condition, you can see we told that only the customer's ID where the ID is equal to equal. So that's about the inner join. Now outer join means even the customers which did not order should be joined. So I'll just show an example. There are two types of outer join, that is the left join and the right join. So it depends on like the position of the table. So if the left join means it joins the whole left table with the right table. Right join means it joins the whole right table with the left table. So I'll just say what we're doing now. So over here we joined the left table, that is the orders table, along with the right table, that is the customers table. So left and the right table are joined. Now these both are joined only if they both have relationships between them. So you can see not all customers are present in the right table. Now why not all customers are present? Because all customers did not order something. So only the customers which have ordered or are there in this particular column in the orders table, only those customers are joined. Now if I say right join, that means bring all the customers even though they have no relation, or that means even though they didn't order something. So if I say right join, now as I said, right join is like an outer join, so I can also say like this. So right outer join. So this is also completely valid, but it looks quite long, right outer join. So I'll just say right join. Okay. So now what is the right table? Customers is the right table. So right join means join the orders and the customers based on this condition. But before, in the inner join, the customers which did not order were not there. But now all the customers will be there. So if I run this, you can see now all the customers are present. You can see 1 was joined, 2 was joined, 3, 4, 5, 6, 7, 8 and 9. But you can see for 5, 7 and 9, for these 3 customers, the order is null over here. Now why is it null? Because they didn't order something. So obviously order ID was not created. There is no order number also, because if they didn't order, then from where order number will come? And there is no order date also, because they didn't order anything. And you can see customer ID also is null, because this customer ID refers to the customer who ordered something. In this case, Ford, Peterson and Joe didn't order anything. So it's showing null over here. So this whole thing from here to here is the orders table. Now obviously in the customers table there is no null, only in the orders table. So you can see we join everything in the right table. Even though they didn't order something, those customers were also present in the right table. But obviously they have a null relationship, because you can see we have all the nulls over here because they didn't order anything. So obviously there won't be any order ID, order number, order date and all that, because they didn't order anything. So there is no order information about that customer, only about the other customers who have ordered it. So that's about right join, because all the elements or all the records in the right are joined. Even though they didn't order something, they don't have a relation, it was not reference, everything was ordered. Now there's also left join. Okay, if I run this, the output should be very similar to just join. Now why is it? Now because left join means, by definition, it means like it's going to join all the elements of the left table or all the elements of the order table with a customer. Now there is no null customer or anything like that, like the opposite of previous one. That's because an order cannot exist on its own, right? So you cannot have an like order number 11 without a customer. So who ordered that order if the customer is not present? So that's not possible. So customers can exist on their own, like customers can exist without ordering something, just normal customer, but without ordering something. This is just like a customer database. So maybe they didn't order something in this shop or something like that. So customers can exist on their own without ordering something. But in the orders table, like a particular order cannot exist on its own. Like obviously there won't be an order if no customer ordered it or something like that. So an order always has a customer ID and an employee ID. So no matter what. So in that case, we don't have any null customer. But in the other case, like in the right join we did, a customer can live without ordering something. So over there, that's why we had like null order ID. So you can see we have like when I type the right join, you can see there are some null orders because those orders were not placed by customers. Okay, but when I type left join, now any order cannot exist without a customer, so they are completely dependent. So order is completely dependent on customers and employee. So in that case, we cannot have an order without a customer. So that's why we have the same output as join. Now for showing left join, what I'll do is I'll change the order of the customers and the order. So I'll put customers over here and order over here. Okay. So now that means left join. So left join means customers. So it's going to add all of the customers, even though they do not have orders they do not have relation with the orders. So in this case, it's similar to right join when customers was over here, but now customers are over here. So now left join will be like, if you run, you can see we got all the customers first, but then we got null orders. So that's about left and the right join. So now left join, so normal join means it's going to join only when they have relation. So in our case, if the customer didn't order something, so if order doesn't reference to any customer, then that order won't be inserted inside the joining. But left join means all the elements in the left table, that is customers table in our case, will be joined. Even though an order was not placed by them, they will still be joined. So that's about left join. And right join means the same thing, but for the right table. So all the elements from the right table will be joined, even though they don't have any relation with the left table. Let's see a visual example about joins. So till now we learned about inner join, left join, and right join. So this is actually a diagram. Okay, so you can see over here, first of all, we'll talk about inner join. This circle is the left table because it's in the left side, and this is the right table. The same thing is for other diagrams also. So this is the left table, this is the right table, this is the left table, and this is the right table. So now let's talk about the inner join first. So our right table was the customers table. So in the customers table, not all customers order something. So we had some customers who didn't order anything. So in that case, so you can see this whole, for example, this is the whole customers table. Okay, so inside this we had some customers. I mean, like 10 customers we had. Out of those, 3 customers did not order anything, and 7 customers ordered something. So in the orders table over here, they were referencing the customers, right? So only the orders table that were referencing the customers, and also all the customers that were being referenced by the orders. So in both of these, the common one is the middle ground. So this only the inner thing will be joined. So only where both of them reference each other, only that part will be selected. So that's about inner join. So in the right join, you can see the whole customers table is selected. Now this part is actually the part where the order referenced the customers, as well as the customers are being referenced by order. So this part is the common area over here. So this part where we saw earlier in the inner join. But we also have this blue shaded area. So over here, first we had so over here we have 3 customers who didn't order anything. So over here they are in the gray part. In the blue part, only the common ones who have ordered. So where in both of these table they have relation. And these 3 customers are just lying around over here in the customers table. They're not in the inner join. But over here you can see we have the inner join, as well as we have the customers who haven't ordered. So over here before we had the gray part, it was not counted. But now they are counted. That's because the right join. So the whole right table is selected. So the whole right table is joined with the orders table. So the whole customers table is joined. Even if they are not being referenced or anything, the whole right table is joined. So you can see over here, even they have the common parts, that is this middle part over here, as well as they have the whole other areas, like the other elements who are not being referenced or anything like that. So that's about the right join. And the same thing for the left join. So in the left join, the whole orders table will be selected, even if it doesn't have any relation with the customers. So maybe an order will not have a customer. Now, obviously that's not possible, but I'm just giving an example, just for example. So maybe just assume that an order doesn't have a customer. So in that case, the order will be left out over here. So over here the orders will be left out because they are not referencing any customer, so they won't be in the inner join. But over here the whole orders table is selected. So even if the order is not referencing any customer, those orders will also be counted in the left join because the whole left table is joined with the right table. So even the common areas as well as the whole other left join, even though if they are not referencing anything. So far we have learned how you can join two tables using the inner join method and also the left join and the right join. So how you joined was, first of all you selected everything from the first table and you joined it using the second table. So first you selected the first table and then using the join command you joined it, and then using the on you joined it based on the condition. So what condition you wanted to join. So now you can see where the orders table, so O is for orders table and C is for customers table. So where the orders table's customer ID field, so over here customer ID field should match with the customers table and the ID field. So you can see, so this customer's ID field matches with the ID field in the customers table. So you can see 33224433 and all that. So it matches like that. Now if I don't specify the condition over here, what do you think will happen? So now we didn't specify the condition. So how will these both table join? So if you run this, you can see we got a very big output. So what happened was it took the first table, joined it with the like this. So it's like you can see all the customers were joined like this. So first table, so so everything over here is actually the first table. I mean like the first order. So you can see order number 111. So this all is the first order. And the first order is joined by the first customer. Sorry, the 9th customer. And first order is joined by the 8th customer. First order is joined by the 7th customer. So all the customers are first joined by the first order. And then again you can see it starts from 9 again. So 9, 8, 7, 6, 5, 4 till 1 again is joining the second order. And then it goes from 9 to 6. So again all the customers are joined with the third order. Then all the customers join with the fourth order. So you can see all the customers are joined with each order. So that's called the Cartesian product. So you're joining like each and every possible scenario. So order 1 with the 9th customer, order 1 with the 8th customer, order 1 with the 7th customer. And then again you got order 2 with the 9th customer, order 2 with the 8th customer. So all the orders are being joined by all the customers. So how it is done is, first of all it takes the first order and joins with all the 9 customers. So you got first order 9th customer, first order 8th customer. So till first customer, till all the customers are finished, it joined all the customers with the first order. And then it goes to the second order and again it joins with all the 9 customers. Then it goes to the third order and joins with all the 9 customers. Then it goes to the fourth order and so on. So until our orders are finished. So now already you can see the output is pretty large. And if you have a larger database like thousands and thousands of orders and thousands of customers, then you can already imagine it's going to be a really large output. So in this case, like in our case, the customers and the the orders is not pretty useful. So we will not be using this without condition, like joining the tables without conditions. So that's about how the Cartesian product. So far we have joined the tables using the join command. So first of all we selected the first table we want, and then we used the join command and joined it with the second table. Now this is not the only way you can join tables. This is actually the preferred way, like majority of the time you're going to use this one. But this is not the only way. Let's look at another way of joining the tables. Now the another way is actually, we're not going to learn anything new, but just all the things we learned it earlier. So you can see, first of all I'll just get rid of join command because as I told, we're not going to use join for joining tables for now. Like majority of the time you're going to use join, but you can also use this if you want. So first of all we're going to select the first table orders, and then we're also going to select the customers table. So you can see we're selecting everything from the orders table and we're giving it an alias. So we're going to select everything from the orders table as well as from the customers table. So we're selecting two tables at once. So first, usually we used to select only one table using the from command, but now we are selecting two tables. Now if you select two tables, the second table is going to be joined with the first table. Okay, and as you can see, we didn't add condition. So this is actually the same as the Cartesian product. So if I run, you can see we get the same output. We got the first order repeated 9 times because we got 9 customers. So each customer is joined with the first order. Then again, each customer is joined with the second order, and so on. So this again, we got the Cartesian product. So you can just imagine this thing as you're joining the tables. So if I actually copy and paste it over here, and instead of this one, I'll just put like join. I'll put a semicolon. So this thing is actually the same thing as this part, because we are selecting everything from the first table. So now we're selecting only the one table, and then we are joining it with the second table. So that is what we're doing. But over here, instead of selecting one table and joining it with another table, we're selecting 2 tables directly. So if you select 2 tables, it's the same as taking the first table and joining it with the second table. So you got a Cartesian product like this, exactly like this. But if you want to join tables based on the condition, we did like this. So on where the orders.customer ID field over here, so orders.customer ID field should be equal to the customers table and the ID field. So the customers table and the ID field. So we did the condition like this. And if you run this, you can see we get the desired output. So the first order was ordered by the third customer, and the third customer is Muhammad, like that. The second order was ordered by the second customer, and his name is Alan. So you got like that. Now if you want to add conditions without using join and on, because this on requires join. If I don't write join over here, like if I comment it out, you can get an error because this on does not exist on its own. It's actually a part of join. So this on always needs join. Now over here, we selected 2 tables. We didn't use the join command. Then how can we add conditions? Yes, we have to use the where command. Now if you remember, the where was used for adding conditions. So again, you can add conditions over here. Now our condition is this. So our condition is the orders.customer ID. So the orders.customer ID field should be equal to the customers.id field. So over here, so you can get this output. So now this output, well, currently over here, so this output, our desired output. So this output we got because of this command over here. Now if I run this command, this should actually give us the same output. So if you run this, the output should not change. You can see we got the same output. First order was ordered by the third customer, so we got the third customer from the customers table. Second order was ordered by the second customer, so the second customers were returned. Third order was ordered by the fourth customer, so the fourth customer was returned. So it's like the same thing, joining tables, but over here, instead of selecting one table and joining it with the second table, we selected 2 tables directly. So it's going to join the first table with the second table. If you don't specify the condition, then it is like the Cartesian product. Over here also, if you don't specify the condition, is the Cartesian product, like you're going to get every single possibilities. Now over here, instead of the join command, we used, instead of joining 2 tables using first selecting one and joining it with the second, we selected 2 tables directly. And for the condition, we already know we have the where clause. So we added condition using the where clause, because this on clause needs like the join to work. It doesn't work on its own. Now there are 2 other types of join, actually 3. So we have the equi join, the non-equi join, and the natural join. So we'll take a look at all of these now. So the equi join is like equi. So equi means like equal. So equi join is actually where you join 2 tables based on equality. So over here you can see we joined the orders table and the customers table, where one field of the first table was equal to one field of the second table. So we use the equal to command over here. So this is an equi join because we used equal to sign over here. So you can see if I run this again, you can see we got like where the customers ID field is equal to the customers ID field of the customers table. So where the customers ID field is equal to the ID field in the customers table. So we join 2 tables over here using the equality sign. So both of these are joined using the equality sign. So that's why it's called an equi join. So we join the orders table as well as the customers table using an equi-join method. Non-equi-join is like completely opposite to equi-join. Now in equi-join, we used equal to sign for comparing two tables, like joining two tables. But in non-equi-join, we're going to join two tables without using the equality sign. So no equality sign means you have other signs, like other symbols. You got the greater than, smaller than, greater than or equal to. Oh, I think we cannot use greater than or equal to because it contains equality sign. I'm not sure, maybe you can use it, but I'll just not write it over here. So we got the greater than symbol, smaller than symbol, and we got the not equal to symbol. So if you remember, this is not equal to. So we can use these three for non-equi joins, but for equi join you can only use equality symbol. So actually let's do an equality join, sorry, non-equi join. So over here I'll just use greater than. Okay, so let's actually first of all, without seeing the output, let's assume what's going to come. So over here, first of all, customer ID 3. So customer ID 3 is greater than the first customer and the second customer. It's not greater than the third customer, obviously. So we're going to get in the output, so the first order is being joined by two customers. It will join the first customer as well as the second customer because this is actually greater than this. So we specified greater over here. So let's run this and you can see over here. So this is actually the orders table. So the second order, sorry, the second customer, not this because we're joining using this. So the second customer is greater than 1. So we joined using 1. Okay. And then we got the sixth order. So sixth order is again second customer. So it's greater than 1. And the 10th order is also ordered by the second customer. So again, it's greater than 1. So it's joined like that. Now the first order was ordered by the third customer. So the third customer is greater than the first customer. And again, fourth order was also ordered by the third customer. So now third customer is greater than 1. So again, it joined. Now the third order, so this is the third order now. Third order was ordered by the fourth customer. The fourth customer is greater than the first customer. And then the ninth order was ordered by the sixth customer. Again, is greater than the first customer. And the fifth order was ordered by the eighth customer. And the eighth customer is obviously greater than the first customer. So we joined all of the orders. So 2, 6, 10, 1, 4, 3, 9, 5. So all of these orders. Okay. So we got first order, second order, third order, fourth order, fifth order, sixth order. We don't have seventh order. And we don't have the eighth order. But we have the ninth order and the 10th order. So all of these orders are ordered by customer ID 2, 3, 4, 6. So all of these orders, so over here, all of these orders are ordered by these customers. And these customers are obviously greater than the first customer because you can see we did the greater than. So the customer ID field in the orders table. So this is the orders table. So the customer ID field should be greater than the ID field in the customers table. So should be greater than this customers table. So that's why you can see first of all of these orders are greater than the first order, right? So all of them are joined. Now again, we're going over here. So first order was ordered by the third customer. So we should get the third customer, right? But actually we got the second customer because we didn't do equality sign. So third customer is obviously greater than the second customer over here. So this whole line. I know it sounds a little bit confusing, but it's actually not confusing. Just see based on what we join the tables. We joined that the customer ID should be greater than the ID field in the customers table. Before we used the equality sign, but now we are using the greater than symbol. So you can see over here, we were over here, yeah. So the first order was ordered by the third customer. So now instead of showing third customer, then it will be equal to, but we're using the second customer because second customer is smaller than this. So we are using like the customer ID should be greater than the second customer. And then the fourth order was ordered by the third customer. So the third customer is obviously greater than the second customer. And then you can see the third order, or wait a second, I'll do like this. So it's much more easier over here. So now all the orders are joined, like all the orders are displayed in the ascending order because I clicked over here. So you can see the first order, second order, third order and all that. So in order, in like the correct ascending order. So you can see the first order was ordered by the third customer, so it's greater than first customer. Then again first order was ordered by the third customer again, because it's greater than the second customer. So we are taking the first customer as well as the second customer. So you can see the first order is joined by two customers, the first customer and the second customer, because the first order is ordered by the third customer, and third customer is only greater than the first customer and the second customer. Now obviously third customer is not greater than the third customer, so third customer is greater than only the first customer as well as the second customer. So the first order is joined by two customers. Now the second order is joined by the second customer. So now second customer is only greater than the first customer, right? It's not greater than second customer or third customer. So second customer is greater than the first customer. So we joined the second order only with the first customer. And now the third order is ordered by the fourth customer. The fourth customer is greater than the first customer, greater than the second customer, as well as greater than the third customer. So you can see the third order. Okay, so the third order was ordered by the fourth customer. So the third order is joined by the first customer, the third order is joined by the second customer, and the third order is joined by the third customer, because all of these 1, 2, and 3 are smaller than 4. So 4 is greater than all of these. So now if you go to the fourth order, you can see fourth order is ordered by the third customer. So now third is greater than 1 and 2. So the fourth order is joined by two IDs or two customers, 1 and 2, because these are smaller than the third one. So you can see so on. So customer ID is joined by the customers which have the ID less than what is specified over here, because this should always be greater than over here. So that's about the non-equi join. So we had an equi join, which is like using the equal to symbol while joining two tables, and we have the non-equi join. So I can use the greater than symbol, smaller than symbol, or not equal to symbol. One last thing I want to show is about natural join. The natural join doesn't need a condition. It's only going to join two tables with the same name. So you can see our condition. We joined tables like orders and customers, where the customer ID is equal to ID. So the customer ID in the orders table should be equal to the orders table in the customers table. Should be equal to the ID field in the customers table. So that's we joined. So we joined using these two. Now what if instead of ID, like in the customers table, so if you can see in the customers table, the primary key is the ID over here. Now what if, like instead of ID over here, I change the name to customer ID, for example. Now if I change the name, you can see both of these fields are equal. So in the first table, so in the orders table, as well as in the second table, that is the customers table. So the first and the second table have two fields in common. So if both of these field name are common, the natural join is going to use this condition. Okay, so natural join is going to see the common field name and is going to join based on that. So based on the equality over here. So instead of like now in the customers table we have ID. So we're joining customer ID with the ID. So now if I go to the customers table, so you can see over here is the customers table. So in the customers table, I'm going to press this icon over here. And this icon is going to allow us to edit table properties. Now you can see the first one is a primary key. You can see the key symbol over here. The first one is a primary key and its name is ID. Its data type is integer. PK means primary key. NN means not null. UQ means unique. And AI means auto increment. So it's going to increment by 1. And then first name is a varchar, last name. So you can see all of these table information we got along with the data types, constraints and all that. Now I'm just going to double click it and you can see I'm able to edit it. So now instead of ID, I'm going to say it customer ID and press enter. You can see we got customer ID over here. So instead of ID, I'm telling it is a customer ID and I'm going to apply it. And you can see this is actually the query being run. So if you don't want to type this, you can just come and, oops, I just copied it. So if you don't want to type this, you can just come to this editing area and edit it. And this app, this MySQL workbench is going to run this command behind the scenes. So just apply, and you can see the script was successful, and close it. And now you can see, now instead of ID we have custom ID. So I'm going to close this, and I'm going to press this button, and you can see in the customers table, before we had over here ID, right? Now we have custom ID, first name, last name, and all that. So instead of ID we have custom ID. Now if I run this, actually this whole part again, you can see over here we have ID, because this part is actually the customers table part. So you can see over here we have ID. Now if I run this, okay, we got an error because we told customers table the ID field, but now we don't have the ID field, we have the customer ID field because we changed it right now, right? So if I actually run this, you can see we have customer ID over here. So from here, this whole part is actually the customers table. So now we have customer ID instead of ID. So now you can see we are joining the first table where the customer ID is equal to customer ID in the second table. So you can see customer ID and customer ID both are common in both of this table. So in the orders table as well as the customers table. So customer ID field is common. So we joined it using the customer ID field because it's common. Now instead of, mentioning it like this, we can use natural joins. Now natural join does exactly like this. Okay, so it's going to first look at the common table name. So it's going to look, okay, so in the first table we have customer ID. So in the second table also we have customer ID. So both of these have the same name. So then it's going to run this thing. So first table customer ID is equal to the second table customer ID. So just like this. Now this one actually we need this join command over here. So over here, so on you can see, so this was the condition. So if I run this, you can see we get the same output, customer ID and customer ID. So now natural join is going to look at the common field name and going to run this. Okay, so the first table dot the common name, then customers table the common name, and then it uses the equality symbol. So now I'm going to get rid of this condition, and instead of join I'm going to use natural join, and I'm going to put the semicolon, of course, or else I'll get error. And you can see in the natural join, so natural join is going to look at the common table names. So we in the first table customer ID and the second table customer ID. So both the customer ID is the common table name. So it's going to use equal to sign. So where the first table, that is the orders, so orders.customer ID should be equal to the customers.customer ID. So you can see we have the same names over here. So natural join is going to join using the same names. Now if I run this, you should get the exact same output. Yes, we got the exact same output. You can see the output is the exact same. So you can see the third customer ID. Actually, we got it like in different orders. So you can see like the order of the columns are a bit different. Before, you remember the customer ID used to be over here, but now it's removed the customer ID from this table as well as from this table, and it put over here in the first. So what I'm talking about is, like, I'll just copy this and remove the natural join and add a condition where the orders.customers ID, customer ID is equal to customer.customer ID over here. Now if I run this, you can see this part is the customers table part. So like the first part, this part is the orders table, So this part is the orders table, right? Over here we have the customer ID field. And this part is the customers table. And again over here we have the customers ID field. So you can see we have customer ID field over here and customer ID field over here. But if I use the natural join, you can see we don't have customer ID over here and over here. What it is doing is going to take all the common table and put it in the first over here. So you can see the customer ID field was the common one, like the common field. So it's going to put like in over here in the first one. So you can see the first order was ordered by the third customer, and the third customer is over here. And the second order, the second order was ordered by the second customer, and the second customer is over here. So you can see natural join actually does like that. So that's about natural join. Natural join is like exactly over here. So it's going to check the common field names and is going to join using that.